So what are the odds of getting a perfect bracket? Many people try every year to write their own bracket for March Madness, and it really is highly unlikely that you're going to ever make it perfect. And why is that? Well, there's 63 different games in the actual tournament. So if there's 63 games, that means each game has 2 outcomes, of course. So 2 outcomes per game. So the number of possible brackets is 2 to the power of 63. So if we do that on our calculator here, 2 to the power of 63, you get a ridiculously large number. It's so big they have to use scientific notation to represent it. So what that roughly means is roughly 9 with 18 zeros after it. Okay, so imagine that's like 18 zeros. And really it's more than that because you've got these 2, 2, 3, 3, 7, 2, etc. So it's even more than that. So that's a huge number. It's really hard to even fathom how big is that? How big is 2 to the 63 besides just saying it's pretty big? So let's think about this. Suppose you could write one bracket every second, which even in itself is impossible. You cannot write a bracket in a second. It takes a few minutes to do if you do it, with thinking. So one bracket every second in itself is kind of crazy, but suppose you can. And suppose you do that every second forever, for your whole life, okay? And suppose you live for 100 years and you only make brackets. Okay, so you don't do anything else besides write these brackets every second, nonstop, no eating, no drinking, no sleeping, no nothing. Every second, new bracket, you're just producing them one after another after another. If you do this, it would take you a ridiculous amount of these 100-year lifetimes. Even in 100 years of doing this nonstop, you would not even be close to the number of brackets that you would need. So let's show this. So here's our total, 2 to the 63rd. We're going to divide that by all the time we're going to spend making these brackets. So we're going to spend 60 seconds in a minute times 60 minutes. This is seconds in a minute, and this is minutes per hour. And we're going to do that for 24 hours, and we're going to do it for 365 days in a year. We're going to just use that. Don't worry about the leap years. And we're going to do that every day for 100 years. So here's our years, here's our days, and this is how many hours in a day. Okay, so that's all of our time we're going to spend making these brackets. I'm actually going to delete that for now. So there's our starting number. So let's figure out how many seconds that is. So 60 seconds in a minute, 60 minutes in an hour, 24 hours in a day, 365 days in a year, times 100 years. It's a lot of time. But look how much different these two numbers are. They're actually drastically different numbers. You can tell by the power of 10 there, 10 to the 18th and 10 to the 9th. If you would just divide those, that would be 10 to the 9th, which is a huge number. It's a 1 with a whole bunch of zeros after it, 9 zeros after it. So it's roughly that, and then you have to think about, well, we got the 9 and the 3. So let's actually divide everything. So let's do 2, I'm going to do parentheses here, 2 to the 63rd, divided by that entire thing we just got from before. So I'm going to do divided by, and I'm going to do my previous answer because I can just kind of copy and paste that in. So there we have it. That's how many lifetimes you would have to spend. So 2.9, and then et cetera, times 10 to the 9th, which is about 2, 9, and 8 zeros. And so I got 7, 8, which is roughly 2.9 billion 100-year lifetimes, which is just incredible. Okay, 100 years of your life only making brackets every second, you would still need 2.9 billion of those lifetimes, which is why it's essentially impossible, because that's just unfathomable how big that is. So are you ever going to get a perfect bracket? Answer is no. Good luck, but no.